So I'm going to try to tie together some of the things that we've been talking about in TDD, and I'm going to try to convince you that even for those of you for whom TDD appears to be a new thing, you actually already know how to do it because you've been doing all of the same things already. You've just been doing them really ineffectively. So before you do that, let me just quickly go through a set of other testing terms you might hear. Testing's been around for a long time, so there's different vocabulary concepts and terms that have come up around it besides the ones that we commonly use. Mutation testing is a really interesting idea, which is basically if I introduce a deliberate error into the app, does some test fail? Because if not, then there's probably a hole in your testing coverage somewhere. And in fact, as a preview, this is essentially how we're going to test. There's a homework that we're going to give out where you guys are actually going to write your own cucumber scenarios. And this is basically how we're going to test it. We have a version of the app where we can insert bugs and make sure that you have some scenario steps that fail because of those bugs. Fuzz testing. So this is sometimes called monkey testing. You basically generate random inputs for your code. In fuzz testing, basically you try to exercise the code in ways it wasn't designed to be used. So if it was a command line program, you can just actually type input at the command line. For a SAS application, it's things like having forms that are submitted with random values or values that are way too long, and or values that have illegal characters in them. Microsoft says that they find about 20% of their bugs this way. There are fuzz tests that can crash up to 25% of the popular Unix command line utilities. So this is a powerful technique once you've done the basic level of testing. If you do this before you've done your basic level of testing, you'll despair, because like any random input will break your app because it'll be brittle. DU coverage, which is for define and use. This is another variant of how you measure test coverage. If you look at every place where you've got some variable that's defined, meaning a value gets assigned to it, and sometime later somebody consumes that value. And the number of pairs of those is a multiplicative in the number of references, right? Because if I define a variable and there's 3 different code paths that could consume the value that I set, that's 3 different DU pairs. So another way that you can look at coverage is of all possible DU pairs, what fraction of them are exercised somewhere in my test suite. And lastly, you'll probably hear terms like black box testing versus white box testing, or sometimes people call it glass box rather than white box. The idea is a black box test is what you do when you either don't have much information about the implementation, or you're really just concerned in testing against an external spec, as opposed to a white box test where you know something about the implementation and your test cases are designed to stress the thing you know. So an easy example of this is if you're coding a hash table, the black box definition of a hash table is given a key, can you get back the right value? But if you know something about what hash function is used inside the hash table, you might create a glass box or a white box test that deliberately tries to create hash collisions because you know how it works. So again, there's subtle nuances in what you're trying to test, but if you hear the terms black box or white box, that's what it's referring to. So this is where I try to convince you that you already know how to do TDD, you've just been doing it in the wrong order. This is how I used to write code. I've been saved. I hope you too can be saved. But I used to write a bunch of lines which I was sure was correct. I would run the lines. Of course, there'd be a bug, and that's a stupid bug. That wasn't me. That was just stupidity. That's no problem. I'll break out the debugger. I'll look at the values of things. I'll put in some printfs to make sure I know where the code is. And once I've stopped in the debugger, I can like tweak or set other variables and make sure that the right thing happens. OK, now continue. Oh, it didn't work. And once I fix it, I'm sure I fixed it, and that's the last bug ever. And of course, it never is. So all of these same steps occur in TDD, just in a different order. You write a few lines, but you write the test first, so you'll know immediately if you wrote something stupid, right? If instead of writing a bunch of lines, oh, I made a spelling error. Well, figure it out now instead of later when your brain is someplace else. And instead of having to put printfs everywhere, just mock or stub the things you want and use an expectation to say, at this point, this value or this variable ought to have this value. Use something like should equal, or use should receive if you're talking about a method being called. What about the part where I stop in an interactive debugger and then I kind of try to very carefully set up the world so that I know which code path is going to come next? Well, that's what mocks and stubs are for, right? We can return canned values from method calls and seams so that we know which code path it's going to go down. And finally, when I get to the part where I was sure that I fixed it, but it turns out I was wrong, well, if you've already done this with the test, you just rerun the test. You have Autotest run it for you, and you keep making tweaks until you get it right. So you've actually already done all of the things that TDD requires. Really, this is just about doing them in a different order, but it's all the same skill set. So my view is that it's the same idea, same skills you've already developed, but you put them, you make them more productive. And the second lesson, which is less obvious, is that writing tests before the code, it does feel like it takes more time up front. And it does take more time up front because you don't realize that you're getting a free benefit from doing it. It's forcing you to think about how the code will be used. It is remarkably common. And I guarantee the following is going to happen at least once. You're going to write a method that you know you're going to need. And you know what arguments it takes, and you know what it's supposed to return. You code it up. You're proud of yourself. Now you go back to the part of the code that was going to use that method that's going to call it, and you realize that you actually weren't quite right about how you were going to call it. There's actually an additional argument you didn't realize you needed to pass. Or actually the return value isn't quite what you wanted. It'd be more convenient if the return value was different. So when you're doing TDD, it forces you to think about that stuff up front, and that's why it takes longer. You're doing little kind of bits of design as you go, so that by the time you get to backfilling the method, like I said, the hard part's been done, right? You figured out the structure of the code and what you need to test about it. Actually writing the code, given those constraints, is the much easier job. So here's what I believe we've learned about TDD. You learn about this idea of red-green refactor, make sure the test fails for the correct reason, then backfill the code, and always look for opportunities to beautify. Your goal is to spend most of your time in green, right? You have to go red when you're adding a new test, and as soon as you add it, write the minimum amount of code to go back to green. So think of it as trying to always go back to the stable state. Test one behavior at a time, and we've seen how you could use seams to sort of intimately control what happens in each test case. Use placeholders. So we saw some examples when we first started developing these that even just saying it should do such and such without filling in the test code, at least it serves as a placeholder to you to remind you that you've got to come back to that test. You can even use the pending keyword so that you'll see a little message printed out in yellow every time you run that case through RSpec. Look at the coverage reports. We will have you run SimpleCov as part of your overall test coverage. It's worth using them not to get sort of religious about where you need to get 100% coverage, but to point to parts of your code that are clearly under-tested. And kind of in hand with that is don't rely too heavily on any one kind of test. There's a reason that many different kinds of tests has evolved over time, and one of those reasons is that different types of tests will catch different errors. So here's a quick question about testing. Which non-obvious statement is false? Even 100% test coverage, whichever metric you want to pick, is not a guarantee of bug freedom. If you can stimulate a bug-causing condition using a debugger, then you can capture it in a test. Testing eliminates the need to use a debugger, assuming you've done the second thing. And when you change your code, you need to change your tests as well. Which of these four is false?